All right, I'm very happy to be welcoming back James Kobielus to Speaking of Data for another episode. Thanks so much for joining us today, Jim. How are
Andrew, I'm doing good. Nice to see you again. I see you quite a lot. It's nice to see you again.
you? Yeah, we do work together a lot these days. But yeah, I'm excited to talk to you about spatial data science today. That's going to be the topic. Um, and I think we recently had a webinar on it that you and I were both a part of that was very intriguing and interesting. So I'm excited to get a little bit further into the topic today. So Jim, if you don't mind, I'll just start off by asking you to provide like a simple definition for what is spatial data science, and then we can get into some more technical questions if that's all right.
Yeah, in a nutshell, spatial data science is data science, but on geospatial data. In other words, location data, on navigation data, GPS data, anything that's geocoded. So spatial data science builds on and extends the capabilities of geographic information systems, and really what spatial data science is. Because it's data science, it focuses on understanding not just where events take place, but also why those events are occurring and what's likely to happen under various future predictive scenarios.
Very exciting. I think, it's easy for me to just know off the top of my head how frequently I'm using spatial data science. I mean, I know I'm using apps for ordering my food or going to pick up my food, or just finding another place to go and eat. Obviously, a lot is revolving around food for me, but there's a lot of other uses that we'll go into. So, Jim, I'm kind of leaning into a question here. So, what would be the principal use cases of spatial data science in the enterprise?
Really, so really the principal use cases are anything that involve the need for location intelligence, in terms of applications, but also in terms of decision support in a business analytics context and the like. And with your intro, you begin to back into the chief use cases for spatial data science in the enterprise. Personalization of everybody's experience with, say, mobile applications based on where you happen to be now. Every single day, I, like you, it's like right now, I'm going through a home remodeling project, and while we're waiting for our new kitchen to come in, my family and I have had to do a lot of takeout. And so we get out our phones and our apps on a daily basis, and it's like, okay, where are the nearest restaurants? Where are the nearest restaurants that serve Thai food that we can take out? In other words, these are the kind of geo spatial applications. So if I happen to be driving 10 miles south of town and I wonder where are the nearest Thai restaurants there, my app knows, because it's got the mapping information, the location information,
Mm-hmm.
and other metadata on restaurants that might be suitable to what I'm looking for. And that gives you a good, strong sense for its geographic intelligence is inside so many applications that we as consumers use all the time, but
Mm-hmm.
also in our business context. So when you look at, for example, in a business context, marketing, geo-marketing, we are all being sent solicitations, offers, promotions of all sorts,
Mm-hmm.
that are very much geared to and targeted at people in and around our particular place on the planet at any point in time. So if I happen to be, say, traveling like I will be soon to Hawaii for vacation, I'm
Nice.
sure that when I land in Honolulu, I'll be receiving marketing promotions geared to people who happen to be getting off the plane in Honolulu, who are coming from the eastern United States, who are probably traveling there for vacation. So it'll also gear those, those ads and promos to people like myself who
Mm-hmm.
happen to be in that place on Earth and who are most likely on a journey, in my case, to have fun. So that gives you a strong sense for the fact that geospatial data science makes this happen. In other words, the tools and techniques of spatial data science can determine where I'm at. I mean, there's obviously privacy issues and so forth. I'm not going to really gloss over those, but I won't be dealing with those on today's podcast. But there's also personalization of my experience continuously based on where I'm at, where I'm likely to be, 1 minute from now, 1 day from now, 1 week from those are so geo marketing and the mobility applications of all sorts. you name it, and also in the business world. Businesses use geographic intelligence, geospatial data science to be able to determine the optimal location for retail outlets, for factories, for offices, based on myriad requirements and so forth. So it's location analysis. It's things like supply chains in terms of logistics and transportation, figuring out where all of your inventory is, or your goods and raw materials are at any point in time, and making sure that you're not overspending on transportation and so forth, making sure that they will get to their destinations on time. This morning, I had a lot of stuff delivered to me for this home remodeling project to my home, and my contractor said they'll be there at or around 10 a.m. your time. And they were at my place at 10 a.m. on the dot. And I thought, wow, I'm sure there were apps that informed my contractor, and they were probably informed by the logistics company they were working with. I'm thinking, the modern world's amazing, and it's amazing that we can anticipate this pinpoint precision in time and space.
Yeah, it's I think you touched on so many things that people wouldn't necessarily think about, how having to interact with geospatial data there on a daily basis. It seems to be everywhere, and obviously it's very, very helpful for all those things. So then, Jim, what kinds of insights should spatial data scientists be extracting from enterprise data?
Yes, and I've really already begun to answer that. So really that comes back to the core of what spatial data science is all about. It's being able to use the tools of data science, that's machine learning, predictive models, and so forth, and to be able to use it to find patterns in location and geospatial data sets relating to where things are happening, why they're happening in those locations, what's likely to happen at those locations in the future under various future scenarios, based not just on location data, but based on any number of contextual variables related to time, related to who it is, what they're doing, what they're attempting to do, and so forth. So the insights that spatial data scientists should be extracting from enterprise data relate to all the geographic intelligence necessary to serve your customers well, to manage your supply chain well, to manage your internal operations well, recognizing that everything is a moving part in the world, human beings, products and services, whole operations, companies open new outlets and close down facilities and reorganize and consolidate facilities all the time, and they do it both on a macro scale across the face of the planet, but also indoors. There are indoor geospatial applications that help organizations to organize things within buildings, within campuses, and so forth. 25 years ago, it's not well known from my resume, but I used to be a product manager at a company that helped wireless engineers to build out cellular networks at a macro scale. But I also helped facilities managers, provide them with tools for GIS tools, geographic information systems tools, for doing indoor optimization of wireless signals, Wi-Fi signals, and so forth, based on any number of variables related to the design of facilities. So geospatial is also useful in indoor scenarios, and geospatial data scientists, are also applying their skills and tools to the issues related to how do you arrange things optimally indoors and outdoors, and also in the interaction where people are coming and going between facilities over long distances.
That's fantastic. Well, Jim, I would love to take a peek at those plans, because my Wi-Fi is not reaching my bedroom to the fullest extent. And I would use your assistance for sure. But
and I wish my contractor had used GIS to redesign the rooms in my house, but we had to do it sort of by pen and paper almost. So they do have computers. So
okay. That's too funny. So then what are the core tools, platforms, libraries required by spatial data scientists?
Yeah, well, it's all the things that I've just mentioned as geographic information systems, which visualize geospatial data and enable complex analyses on that data. It's data, this all the tools of data science. It's data mining, it's predictive modeling, it's machine learning, it's data visualization capabilities. So you can overlay various, like weather and socioeconomic information and so forth over maps in various ways and combinations. So you can visualize various patterns in a geospatial context, like for environmental analysis. Environmental analysis utterly depends on mapping data. In fact, my stepson in Australia is getting his master's in environmental engineering, and they need to do that job. They need to, in many ways, to have mastered the tools and techniques or an understanding of what spatial data science is all about for managing the world in which we live, pollution levels, sustainability, and so forth. But so there's data visualization. There's also, of course, you need navigation data, GPS data. In many ways, you need geocoding tools because, for example, geocoding, being able to code existing data with geographic coordinates, absolutely essential in a consistent way. So if you geocode your spatial, your customer data, your facilities data, and so forth, and you do it in a consistent way across data sets, then you can correlate and overlay all these data types in very powerful ways. So you need the tools of geocoding to drive another application I failed to mention, which is that of geospatial data science, address management in terms of being able to consolidate all your customer data down to the single record version of truth of where that customer actually lives and so forth, but also so that you can geocode that information so that if, for example, and I'll give a very relevant example to where I live in Fairfax County, Virginia, just south of Alexandria. We're right now in the process of renaming local streets and roads, which were named for Confederate generals and so forth long ago. So that process is ongoing. When those new names, like Van Doren Road right near me, when that gets renamed, and it'll have a different name, but you know what? Renaming of streets and roads should not screw up anybody's mail management software. So anything that addressed to, like for example, Edison High School on where my kids graduated from on Van Doren Street. Whatever the new name of Van Doren Street is, any mail that's addressed to that school or any other location on that road should get there because there should be behind the scenes mail address management tools that are able to apply a permanent geocode to the existing address so that when the naming and numbering of facilities on a street is changed, nothing gets screwed up. The mail will still be delivered. That is a core and mainstream enterprise application of location intelligence and has been for a while. And geospatial data science, that's one of the core, libraries or tools that they use and they need.
Well, that's important. I mean, I've just moved into a new house a few months ago, and I'm very thankful that my mail was able to show up when we got here, even though maybe not 100% of the mail, but most of it made its way here. So that's very important to me anyway, on a personal level. So Jim, how should enterprises invest in order to future-proof their spatial data science practices?
Yeah, I've laid out one of them, which is you need very strong, it's master data management is the fundamental thing I'm describing. So customer information management and so forth needs to be integrated with geocoding and permanent addressing that is geocoded, so that as your customers move around, always where they're at, what their actual address is, so that you can, for example, continue to have mail delivered reliably to them, and they can continue to receive the things that they depend on from you as a business, such as, invoices and so forth. So nothing gets screwed up there. that, in terms of future proofing, that's a bare bones thing. What you need for spatial data science and data scientists as an organization is you need to recognize that spatial data science is a core enterprise focus area for your data science practices. You need to staff up with data scientists who are skilled and knowledgeable on the tools and techniques of spatial data science. So you should hire for that. You should evaluate candidates for data science positions based on that, among other aspects of their knowledge. You need to provide internal training resources and curricula to train your existing data scientists on spatial data science and on the new tools and techniques for all of that to future-proof. To future-proof, you also have to recognize that spatial data is huge and getting huger, and it's getting ever more varied as you pull in geo data from everywhere, from customer data, from product data, from facilities data, logistics, et cetera, from the edge, from the Internet of Things and so forth. Everything needs to be geo-coded and so forth. But that's a lot of data. And so you need cloud computing. You need the scalability and elasticity of cloud computing in order to be able to elastically support the storage as well as the intensive processing, analytical and otherwise, of that data to do things like name and address matching at high speed, and so all of that in the cloud. You need to also, like I said, you need to have invest in strong geocoding capabilities so that every piece of data that comes in to your organization is automatically geocoded, and so that geo address is persisted permanently, so forth. But you also, very much for future proofing, you need a strong stack of spatial data analysis tools. Like I said, it's data science, it's GIS, it's data science, data visualization, and so forth. Simulation tools, you can simulate alternate scenarios from a geospatial standpoint. You need a strong stack of all those capabilities. You need a strong team of spatial data scientists to work with it all. You need a strong and scalable data lake in the cloud to manage it all, or data lakehouse. Because when you're talking about geodata, most of it's very highly structured data. So it needs to be a data warehouse, but also a data lake, because there's new sources of geospatial data coming from the social media, from the Internet of Things and so forth, in various semi-structured formats and unstructured for that matter. Things like, over time, as we look at things like large language models coming into this realm as well. Large language models are trained to find patterns in vast heterogeneous data sets fairly rapidly. So, consider, evaluate to what extent large language models, are suitable for incorporation into your spatial data science platforms for various applications, that you have a team that has a strategic focus on continuing to innovate in terms of the capabilities you bring into your geospatial data science capabilities to stay up to speed in this area.
That's very interesting, and I can see the this little portion of data and analytics really growing in coming years with different technologies and advancements, and even just like more on that personal level. Like, we're so used to tracking everything that we do, that we order, where to go. So I think some exciting stuff's going to happen in that space. But I want to shift a little bit and ask you about, like, what about the ethics and sustainability and responsible governance implications of spatial data science?
I'm glad you asked, because in your last thing you said before you asked that question, you introduced the word tracking, and that's what geospatial data enables enterprises and others to do highly effectively, is to track where we are at all times, where we're likely to be going, where we've been. There's privacy implications here. Clearly, in terms of future-proofing your spatial data science practices, one key thing is you need to build the guardrails into your management, responsible management of geospatial data. so you can be compliant with all the regulations, laws, but also sensitivities related to tracking and surveillance and privacy, invasions and so forth. So you can stay on the side of the angels, and your data scientists, your spatial data scientists, can make sure that as they do amazing things with geospatial data, they're not running afoul of any ethical concerns related to privacy, bias. I mean, geographic data is often easily associated with socioeconomic variables of race, national origin, religion, and so forth. So you have to make sure that you're not using, intentionally or inadvertently, location intelligence to discriminate unfairly against parts of the population. Sustainability. We're talking about data science and machine learning models, and we're talking about increasingly huge models able to process, as it were, millions to billions of features or facets, or what the word is. It'll come to me in a second. We're able to look at 10 million different variables related to our geospatial location and other aspects of where we're at. These are massive machine learning models that take a long time to build and train, and then to retrain, and they consume a lot of energy and other resources. So if you don't want your geospatial data science, dimensions is the word, thank you, Jim, geospatial data science models, as they proliferate into the billions of dimensions, become a huge carbon, have a huge carbon footprint, then you have to start thinking through how you're going to do highly sophisticated and complex geospatial analytics without becoming a huge contributor to global warming. And so that involves things as, adopting renewable energy sources to power your centers and all that. But also looking into reusability. There's a thing called a concept called foundation models, that these large language models are an example of them, which is essentially, if you train a model like a language model like GPT-4 on a huge data set, it can do amazing things, not just for the tasks for which you've designed it, such as auto-generating, authoritative looking articles from simple textual prompts. But also, these foundation models can be easily adapted to new tasks without a whole lot of or any retraining, with just some minor tweaks and fine tuning. That's reusability. And to the extent that with geospatial data, as it leverages foundation models, and there are a growing number of them in this regard, then that means you can reuse the models you've already built for your next geospatial challenge and the next one beyond that. To the extent that you can maximize the reusability of the models you've already built, that means that's much less retraining that needs to be done. Hence, that's, in theory, much less carbon that would be introduced into the atmosphere. So if you see this scenario here, the extent that we can build and train and deploy more geospatial data science applications from foundation models that can be wicked smart, but also not wicked in the bad sense of, warming the earth, and, with all the things we've been seeing in recent times, such as vast forest fires that are, whatever, seriously, these are all consequences in many ways of the warming of our earth. So responsible governance of spatial data science, it's, responsible. And at TDWI, we recently published a best practices report on responsible data analytics. Responsibility is sustainability on a planetary level, but it's also being responsible for our models' impact, our analytics impacts on society. In other words, privacy, bias, ethics, toxicity, and so forth. And it's also being, responsible for just the good governance of these models in terms of, are they based on the best data? Do you have the latest and greatest spatial data in your data lake to build these models? What I'm getting is that, so there's the core governance that every data scientist does as a standard practice already related to having the best data and the best models in line, but also, making sure that whatever data and models they build from geospatial sources very much contributes to societal good as well as to the fate of the planet.
Mhm.
So I'm ending on a very global note here.
Absolutely.
So yeah,
No, but all very important. And, we don't want people tracking us. We don't want the Earth heating up any faster than it already is, and we don't want things to be biased. So that's all very important aspects of what we hope to be a fruitful future, potentially, shepherded in by spatial data science. So,
yes,
um, Jim, I really appreciate you taking the time out to talk with us today. This topic is very fascinating to me, and
it is.
I think maybe we could revisit it in a little bit longer if there's some sort of advancements or changes or anything that happens. I would love to
Oh,
talk
there'll
more
be
about this with
plenty.
you.
Yeah,
Yeah.
Andrew, this is so fundamental. So we could easily spin off any number of discussions based on this, but I
Mhm.
think we don't want to tax our listeners' attentions today, so we might want to shut down the podcast before we just keep on wagging our tongues. And
Absolutely. Well, it's always a pleasure, Jim. I hope you enjoy the rest of your day. Thanks so much for stopping by.
Andrew,
Take care.
bye.